Alright, this is going to be a whiteboard lesson. It's going to be a theory lesson, just covering a little bit of the maths that we're going to use to set up the cables.
Okay.
The cable setup is actually my favourite part of the bridge asset. I really enjoy maths, and there's a nice use of some simple maths to set up the cables. It uses some vex, and yeah, I really like it. It's a very sweet setup. So this lesson is going to cover the basic theory behind what's going on, because without this it would probably be very confusing when we jump down into vex. So let's think about our curve, and let's think about having a line which represents our curve. And we've got the 2 points either end.
Okay.
And this curve will represent the start and the end of our cable. So let's map a value onto that, which ranges from, that is a 0. Let's clean that up rather than drawing another circle. So that ranges from 0 to 1 along the length of the curve. Let's draw an arrow. So we've mapped a value that goes from 0 to 1 along that curve. So what if we were to start basically to graph this value? So let's draw a very simple graph, such that we have the start of our curve is here, and the end of our curve is here. And how does this value change along that? Well, at the start it's 0, so it's here, and at the end it's at 1. So this is a graph of the value going from the start to the end of the curve. What if we were to call this value t? And then what if we were to graph 1 minus t? Well, 1 minus t would, when t is 0, at the start of the curve it would be equal to 1. And at the end of the curve, when t equals 1, it's 1 minus 1, it equals 0. So you end up with a curve that runs in the opposite direction. So we've got our value which runs from 0 to 1, but we can take that value away from 1 and quite happily have a value that runs from 1 down to 0 from the start to the end of the curve. So we could take these and we could multiply these by positions, by start and end points, such that if I was to drop a new layer into Photoshop and hide out the first one and draw myself up a quick graph again. Awesome. So let's say that we have our 1 minus t, which was our curve that went this way, multiplied by a value 1. And we had our t value, our curve that went this way, multiplied by a value 2. Well, let's say that value 1 is somewhere here and value 2 is up here. These are just random numbers that I'm picking. Well, we saw that 1 minus t would go from 1 down to 0. So 1 minus t times value 1 would go from value 1 down to 0 across the length of our curve is going from start to end. So that would look like this. And our t times value 2 is going to go from 0 to 1 times value 2, so 0 up to value 2. So it starts at 0, but at the end it's going to be up here at value 2. We got some crazy fading going on. That's a bit better. Okay. So this is value 2 and this is value 1. So what if we were to take these and add them together? We'd actually get a line that went from here straight up to here. So we get a line that basically goes from value 1 at the start of the curve, and as we progress to the end of the curve we move up to value 2. So we get a linear interpolation, and this is basically the area of mathematics that this comes from, is interpolation. We get a linear interpolation from v1 up to v2. So what if we were to add in a third curve that starts at 0, ends at 0, so we always go from v1 to v2, but changes how we get there by having some form of curve between those. I missed a point. Imagine that went into the end point. Some form of curve that we could change that curve that went a point there that we could control. If we were to add that in, the start is equal to 0, so we're still at v1, and at the end we're equal to 0, so we don't change this point. But as we progress between those two, this curve is going to change how we get there, so we can make a curve that comes up like this, or we could have a curve that comes down underneath. So we can change the arc of the curve based on this middle parameter. the way that we get a curve that starts at 0 and ends at 0, well, we've seen that 1 minus t will always end at 0, and t always starts at 0. So what if we start off by taking 1 minus t and multiply that by t? That's going to give us 0 at the start and at the end, and it's actually going to give us a quarter in the middle. Why a quarter in the middle? When we're at 0.5 for t, we have 0.5 times 0.5, and that gives us 0.25, a quarter. What if we were to take that and multiply it by, let's call it VC for V control, basically our control point that's in the middle, and that's going to give us, if we were to add that in as well, that's going to give us this ability to control the shape of the curve. So we're actually going to use the maths behind these graphs to control our use a Vex network that uses this maths to control our curve to set up the cables for the bridge.
Okay.
So we can control our start point, our end point, and the arc of the curve.
Okay.
So with that, that's actually all the theory out of the way. So thank you very much.